Hey everyone, and welcome to today's Explainer. Today, we're going to treat the Earth like a massive architectural blueprint. We'll be looking at how the physical shape of our planet doesn't just sit there, it actively dictates the rules for life itself.
So here's a question for you. How does the actual physical shape of the Earth dictate the shape of your life? I know, it sounds a bit philosophical, right? But as you'll see, the ground beneath your feet has actively engineered human history, agriculture, and even biological evolution. We've got a lot of ground to cover today. Literally, we'll start with the foundations of civilization, then dive into hidden karst landscapes, check out dynamic river deltas, hop over to islands as evolutionary labs, and finally wrap up with protecting our fragile Earth. Okay, let's jump right into Section 1, the foundations of civilization, specifically mountains and plains.
Just picture these towering mountain peaks for a second. They aren't just pretty to look at, they act as massive water towers for the entire planet. With those broad bases and steep slopes, they catch precipitation like a giant funnel. And those melting snowcaps? They feed the rivers that literally keep all downstream life and agriculture going.
Now, what's really mind-blowing here is the sheer global scale of these dramatic landforms. I mean, whether we're talking about the towering Himalayas hiding Mount Everest, the Andes with Aconcagua, or even isolated giants like Kilimanjaro over in Africa, these elevated peaks dictate the weather patterns and freshwater distribution across literally every single continent.
So as all that water naturally flows downward, it eventually hits flatter terrain. And here's where geography gives us a fascinating trade-off. Plains? Well, they're generous. They give us incredibly fertile soil, agricultural hubs, easy transport, which is why they're super populated. But historically, totally defenseless against invasions and extreme weather. Now flip that and think about elevated plateaus. These are like natural fortresses, absolutely packed with rich minerals. But the catch is, they're geographically isolated and they suffer from severe water scarcity, mostly because, water naturally flows away from them down to lower ground.
All right, moving on to Section 2. The hidden karst landscapes, or as I like to call it, the underground world. To really grasp this environment, we first need to know what we're even dealing with. Karst is basically a landscape that is slowly, literally dissolving right under our feet. It happens when soluble bedrock, think limestone, marble, or dolomite, breaks down over time. And it creates these totally alien-looking habitats. We're talking caves, sudden sinkholes, hidden springs, and these incredibly complex underground drainage systems that move groundwater super fast.
Think about the physical reality of a remote karst sinkhole up in the Northwest Territories. It is an environment so special and honestly so fragile that world-renowned karst expert Dr. Derek Ford actually believes parts of this region, right along the Cannell Trail, absolutely deserve UNESCO Geopark status.
When you consider these raw, porous limestone structures, you start to see how they host these incredibly unique microclimates. Because the temperatures underground barely fluctuate, they offer the perfect, stable shelter for specialized animals, bats, snakes, even Dall's sheep. Oh, and they also act as these amazing natural preservation vaults for ancient fossils.
And this little plant perfectly captures the hyperlocal magic of karst ecosystems. Thanks to the unique nutrient loads in these dissolved soils, this globally rare mossgrass manages to survive way up in the Northwest Territories. Get this, it miraculously thrives a full 1,700 kilometers further north than its next closest known habitat. That's roughly the distance from New York to Florida. It's a massive biological anomaly made possible entirely by the chemical shape of the rock.
Okay, let's head back above ground for Section 3, dynamic river deltas, where the rivers finally meet the sea.
These incredibly dynamic coastal landscapes are actually categorized by the natural forces battling it out to shape them. First, you have fluvial-dominated deltas, like the Mississippi, where the sheer power of the river just completely overpowers the ocean. Then, there are wave-dominated ones, where high wave energy smooths out the shorelines. You've also got tide-dominated deltas. Think of the massive Ganges-Brahmaputra, where strong tidal currents carve out these deep, dramatic channels. And finally, estuarian deltas, which form these cool hybrid landscapes in enclosed lagoons.
Now, to put this into perspective, think about the sheer density of human reliance on these tiny, shifting slivers of mud and sediment. Deltas occupy less than 1% of the Earth's surface. Less than 1%. Yet, because they are so incredibly fertile and packed with aquatic resources, they support 5 to 7% of the entire global human population. That is over 560 million people living their lives on some of the most shifting, low-lying ground on the planet.
Let's cross the open ocean now for Section 4,
Islands as evolutionary labs looking at isolated biodiversity.
To really appreciate the magic of islands, you have to understand that their extreme isolation turns them into unique biological laboratories. This isolation sparks the evolution of what we call endemic species. These are plants or animals that are native to and strictly restricted to one specific geographical area, meaning they are found absolutely nowhere else on Earth. Just take a second to process this number: 304,103. That massive figure represents all the vascular plant species recently analyzed by scientists to understand global biodiversity. It is essentially the comprehensive master checklist of the Earth's known flora.
But when we break that massive number down, we see something truly astonishing. Nearly a third, 31% to be exact, of all native plant life is restricted entirely to islands. Now, why is that mind-blowing? Well, because islands themselves only make up a tiny 5.3% of the planet's total landmass. It's wild.
This just goes to show how incredibly dense and precious the evolutionary output of island habitats really is. Out of all those island plants, over 63,000 are island endemics. That means a staggering 21% of the entire globe's plant diversity is locked onto these tiny, isolated patches of land in the ocean. We are talking about over 1 billion years of totally unique evolutionary history, just sitting there on these little specks of land.
Which brings us to our final stop, Section 5, Protecting Our Fragile Earth, and the modern collision we're facing today. When we look neutrally across all our scientific sources, what we're observing is a severe, accelerating conflict between human infrastructure and the fragile limits of our geography. For instance, 55% of all documented global plant extinctions, they happened on islands. Yet only 6% of single-island endemic species actually live in UN-protected zones. At the same time, global sea levels are creeping up at 3.6 millimeters a year, threatening to just drown those heavily populated river deltas we talked about earlier. And to make matters worse, upstream damming has choked off up to 70% of the natural sediment those very same deltas desperately need to rebuild and survive.
In stark contrast to all that modern data, consider this ancient text from the Atharva Veda. It says, "The earth is my mother and I am her child." This ancient, reverent thought perfectly captures our deep, undeniable connection to the plains, the plateaus, and the coasts that sustain us. We are entirely dependent on the physical forms of our planet.
So I'll leave you with this final thought for today's explainer. We've seen exactly how mountains feed our rivers, how plains feed our massive populations, and how islands serve as these irreplaceable vaults of biodiversity. But as we continue to exploit and alter these diverse landscapes, what choices are we going to make to protect our planetary mother? Really think about it. If the physical shape of the Earth dictates our lives, what will our lives dictate for the future shape of the Earth? Thanks for joining me, and keep exploring the incredible blueprint of our world.